I have chosen it as my career path in my life. So it's very good to talk about to you all regarding the opportunities in this particular field, because earlier it was very I would say conventional type of field, which is a sub branch of mechanical engineering. But nowadays it is not like that, and that is what interests everyone. That the whatever the transformation or shift is going to happen in the automobile engineering or automotive industry as a whole, will be needing skilled professionals and basically who are able to correlate the mechanical part as well as the software part, which is the major I would say major or key factor in the modern cars or modern automobiles for that matter. So without wasting any further time, I will start with the actual webinar. So this will be the agenda for today. I will quickly introduce myself to all of you. Then we will see basic overview of market, what is exactly happening in the current automotive market, what people are worried about, or I would say how the conventional era will come to an end and the modern vehicles will be leading the automotive market hereafter. Then the hybrid workspace. So hybrid workspace is something interesting where the automobile engineers will be the key players when we talk about this hybrid workspace that we will discuss during that point. Then we will quickly touch upon some trending roles. So what roles you can look for once you get into the market after completing your BTech in automobile engineering. Those trending roles I will be talking about, and then what Symbiosis Skills and Professional University is offering to all of the students, whoever are interested to join for BTech automobile engineering. Then the forum will be open for discussion. If you have any specific questions in your mind, we can take up in the last 10-15 minutes of the session. So as Roshan sir introduced me to all of you, so I am a alumni of 2021 batch for Symbiosis Skills and Professional University. It has been a great journey there for 4 years. So the structure, the core structure allowed me to do multiple internships right from the first year. So whether the internship is a long internship or a short internship, you get to learn a lot of things when you actually go to the industry and try to understand what exactly the professionals are doing in there. So right now I'm working as system software engineer at Bosch India under Bosch Global Software Technologies. So I'm mainly focused on Jaguar Land Rover projects, and I am into the powertrain controller, so which is the Bosch monopoly in the automotive market as of now. So engine control units, braking systems, whatever it may be, you will find a Bosch controller and a software which goes into any vehicle, maybe it any luxury vehicle or a modern say a mid-range car. Also you will find the Bosch components everywhere. So I am responsible for say powertrain system engineering for hybrid as well as electric powertrains for future Jaguar Land Rover platforms. I previously worked with Device Electronics Private Limited, again as an automotive systems engineer. Actually, I did my internship with them when I was in my final year at Symbiosis. So after the internship, I was also liking the work, and they also liked the working. So they gave me the offer there, so I continued for another year, and after that, I switched to Bosch, India. I have been active trainer for upskilling programs for major OEMs. So as I have already mentioned that I'm very passionate about the automotive field itself. So sometimes you will be feeling like there is a need of say training on the modern areas like ADAS, that is that is the first step of, I would say, autonomous driving, which will be the future for our cars, where driver is not at all required. Sometimes you will not even find the steering and other controls like brake pedals and accelerator pedals in the car, and the software itself will be capable of driving your vehicle for you, and you can just sit and relax and commute from your point A to point B. So something like ADAS, smart vehicles, or electric powertrain or electric vehicles. These are some niche areas, and which will be impacting the automotive industry in future. So these areas, sometimes OEMs will require detailed training, and that's how I have been part of these upskilling programs, which will be arranged for major OEMs in India. So this was my short introduction. Now we will see the basic overview of market. What exactly we are expecting in next, say, 5 to 10 years of time. Because right now a lot of things are changing in the automotive sector. We have been seeing these electric two-wheelers penetrating in the market. Now slowly that will start again with the three-wheelers, then the passenger cars, and ultimate goal will be electrification of the commercial vehicles as well. Now also the buses which we have, the passenger buses for say intercity and intracity travels, they are being electrified by Ashok Leyland or Tata Motors, whoever is the major player in the particularly bus segment of commercial vehicles. They have started introducing the electric powertrain to the commercial vehicles. Definitely it is in the early phase, but we are expecting that in the upcoming, say, 5 to 10 years of timeline, if we focus. So that will be the biggest transformation, because till now whatever cars were manufactured, they were with the conventional powertrain. Very few cars were with the hybrid powertrain, but that also very basic, I would say, layout of hybrid technology we will be dealing with. So now this transformation will be needing the skilled youth. Specifically, I am highlighting this word skilled youth because whoever has been in industry for more than say 15, 20 years, it's difficult for them to reskill, understand the electric powertrain, and get adaptive to the upcoming transformation. So there will be huge requirement in the market considering this particular transformation, and this is regarding the powertrain or cleaner mobility, green mobility, and so on. Apart from that, there will be one more part where we will talk about use of modern technology, where this ADAS features, like many of us have seen in the latest Mahindra XUV 700, that they have introduced these some of the ADAS features like blind spot detection is there, then the automated emergency braking is there. So these ADAS features will start penetrating in the vehicles which are in the market with the conventional powertrain as well. So that is also one part where the skilled youth, or say skilled professionals, will be required, and this will definitely generate the new opportunities for right skill set. And in this particular case, the experience will not matter much, but if you are skilled, you know what exactly you are doing, then definitely you have a huge scope or great opportunities in the automotive market if you have the right skill set. Here They might not even consider the experience. So if you see all these German OEMs like Volkswagen or Volkswagen Group, which will have Skoda, then the Audi and everyone in it. So you will see, if you see any job opening from these OEMs, not specifically in India. Right now, they are hiring for other countries, but soon they will start hiring for India as well. So you will see these job roles will not have any experience required written. Most of the times, until now, they will be writing that minimum experience required is 3 to 5 years or 5 to 7 years. That you will not be able to see nowadays, because they are in need of right skill set rather than the experience. So if you have the right skill set, it is very much say desirable by the OEMs, and there is a chance of you getting into one of these companies. So I would suggest each one of you, whoever is thinking to pursue your career in automotive industry, try to find out the area which interests you a lot and try to build your skills around that particular area. So like powertrain is there, this ADAS, autonomous vehicles, this topic is there. So any topic which interests you, you can build your profile accordingly right from the first year or second year, and then it will be better when you are actually entering into the job market. So next part is the hybrid space. So this is interesting, say, topic for me whenever I look into it, because if you see on the left hand side of the screen, we have one vehicle which is highlighting some of the key features like Wi-Fi, self-driving, in-car connectivity, night vision with pedestrian detection. So this is definitely becoming a modern vehicle, which was conventional earlier. So if we look before 1980s, whatever was the scenario, the cars were purely mechanical. There were very less electronic components involved in any vehicle, apart from the electrical system like headlights, indicators, and your horn. These things were definitely electric, which were operated based on the auxiliary battery of your car. But later on, this got changed with the introduction of vehicle electronics. So vehicle electronics or automotive electronics is something where you will be dealing with the embedded systems. You will be having microcontrollers that is ultimately called as electronic control unit, and these will be responsible for controlling various operations. So this will reduce the amount of wiring you need to do inside the vehicle. One controller is capable of handling multiple, say, operations or processes which will be going inside a car. So if we see engine control module plays a critical role in the efficiency and performance of the engine. Earlier, if you see the old cars which were purely mechanical, the fuel efficiency as well as the performance was very less. So if I talk about, say, there was two cars earlier, Premier Padmini, that is commonly known as Fiat, and the Ambassador, that is from the Hindustan Motors. So if you see, these were very raw cars, or say piece of engineering, where everything was mechanical. So their efficiency was not that great from the fuel economy point of view as well as from the performance point of view. But when the electronic control units were introduced, the efficiency factor changed, the performance also increased. Nowadays, we are able to claim 25 to 27 kilometers per liter in a diesel car, or for petrol, it will be varying from 20 to 22 kilometers per hour. So that is a great jump in the efficiency perspective, and this only happened because of the vehicle electronics part, where your electronic components, your software, the embedded system can efficiently control the process. For example, in engine, the injection, then the exhaust, all these things will be controlled by this engine control module, and it will be very efficient. So this transformation is from conventional to modern vehicles, and now we are in the phase where we are going beyond the electronics, I would say, or the embedded systems which we were relying on, and now we are talking about the cloud connectivity, connected vehicles, smart vehicles, where your car will be able to connect with the other car on the road and exchange the required data. So for example, there was a traffic jam and one car is stuck. So that car will be able to tell other cars connected to it whether there was a traffic jam or any other issue, road closures or any blocks. So that can be communicated from one car to another car. You need not to even open your maps and check for the traffic conditions. So that is the futuristic approach we are talking about. Then the self driving, that is again autonomous driving, that is also upcoming, where we will be using model technologies like radars, lidar sensors, whatever we have been seeing. So that will be used in order to drive your vehicle. So that is something definitely is interesting as well as challenging, because the automobile is a safety critical environment. Any vehicle is safety critical environment, because whoever is sitting inside, uh, the life of that person or passenger, driver, anybody, and the person who is outside, the pedestrian in the nearby surroundings, is also at the risk if we do not take proper care and the safety measures for these modern technologies. Then we have again, as I talked about cloud connectivity. So when we talk about electric powertrain, definitely we have lot of data which we can store centrally in the I would say cloud, like battery capacity, then the charge time, discharge rate. Based on that, these OEMs will be able to update their technologies, battery packs, the powertrain overall, in order to get the better efficiency in terms of range per charge. So that will also have the major say role. So here data science will be coming into picture, where data logging, then the processing will be taken care. So if you see now, there are many say engineering areas which will be involved in the modern cars or modern vehicles. It was earlier purely mechanical, I would say. Then it got some say got some role of electronic engineers, electronic and telecommunication engineers, instrumentation engineers. Now computer engineers are also able to get into the automotive field because of these modern technologies. But still there is one niche area, because computer engineers will not be aware about the mechanical systems in the vehicle, and pure mechanical engineers will not be aware about the electronics, or I would say the computer computation, the software in the vehicle. So automotive engineers will have a greater scope in this hybrid space, because they will be having some knowledge of mechanical systems as well as the electronics part of it. That's how you will be having vehicle electronics, automotive instrumentation, robotics and automation. These kind of subjects will be there during your coursework. So you have a greater idea about the car, not only restricting to the mechanical side of the vehicle. So this hybrid space is something where automotive engineers will be able to grab the opportunities in the market, because of the higher say or upper hand from the mechanical side as well as from the software side. So now if we talk about some job roles, we have understood the market condition or the scenario. Then we talked about what exactly the hybrid space will be created. Now we are interested into the job roles. So whatever you see on the screen are some of the say common job roles which were there earlier also. So automotive design engineering, so whatever is the aesthetic look of your vehicle, how it will be, how it will look like. So somebody who is interested in that area, being an automobile engineer, you can take up that role as automotive design engineer. Then mechanical design engineer, so still, even if we are talking about say modern cars, introduction of modern technology, software in the cars, still the core mechanical parts will be there. You cannot replace a wheel with a software, you cannot replace a chassis with a software, you cannot replace say a transmission with a software. If we talk about electric powertrain, the motor as a say component, it will be a mechanical and electrical component. So there you will need mechanical design engineers as well. So that job role is still there for you if you want to, and if you are interested in that particular area, where you will be using various 3D modeling softwares in order to design these mechanical components, which will be ultimately used in the cars or any modern vehicles as well. Next will be the testing and validation engineer. So testing and validation is again very important, say I would say area, because when we talk about testing of any car or validating it, then it is very important that it is done very properly and by a skilled engineer. Because if there is any mistake which is not identified during the testing and validation phase, when the car is in market, it is very difficult to call back the thousands of cars if any defect is detected. So it is totally in hands of testing and validation team, I would say, who are responsible to find out any defect or any bug at the earlier stage before the car is released in the market. So this is also key role, I would say, if you're interested more into the testing and validating the systems, playing with the system by giving various inputs at the maximum side as well as minimum sides. For example, if you are testing your vehicle at minus temperature, minus 10 degrees, minus 15 degrees, and you are taking your vehicle to plus 60 degrees also. So that is also possible in order to test the reliability of your car. So something that if interests you, then the testing and validation role will be best fit. Then the simulation engineer. So simulation engineer, this particular role is recently, I would say, opened, because these days we have many modern softwares which can help us to do the simulation before even we design or before even we manufacture any particular component or system. So now if we talk about the electric vehicles, you might have heard about the thermal runaways of many two-wheelers. Thermal runaway is nothing but the two-wheeler or car got overheated, and due to the excess temperature it caught fire. That is also happening these days, during especially during summertime. We have came across these situations where the two-wheelers were catching fire, and that was because of the thermal runaway of the overall say battery pack as well as the e-machine which they have installed. So this can be say the risk can be reduced by simulating it. In case of simulation, you can give the input of whatever temperature you are expecting, and then you can see how that particular battery pack is behaving right at the cell level, then the module level, and as a whole battery pack also. So if we look into the lithium ion battery pack construction, there are multiple things which we need to consider, and it is very critical to handle as a system as well. So the software needs to be very intelligent. If it is not intelligent, then definitely the thermal runaway will be there for your battery pack in the future, if not immediately. So simulation can help you understand which are the critical areas where temperature will be increased, and accordingly you can design your cooling system, whether it is air cooled or liquid cooled or whatever it might be. But the areas which are getting most of the heat when battery pack is operational, that areas can be identified through the simulation. And this role also has lot of demand and scope right now in the market, because nobody wants to risk the life as well as risk the brand value by releasing the vehicle in the market. Recent examples are there, like two big players who were competing in the two-wheeler industry. Both of them suffered thermal runaway, and now definitely people will be thinking twice before buying the electric two-wheeler as of now, because later when technology is advanced, definitely the risk will be reduced. But for that matter, the simulation engineering role or simulation engineer is in demand right now, considering the introduction of electric powertrain in the automotive sector. The next is the functional safety engineer. So you might have heard about ISO 26262. This is the international, I would say, standard for functional safety. So functional safety has recently came into the picture. Definitely the safety monitoring was there even earlier, but the specific role for functional safety engineer or functional safety assessor, then the functional safety lead, and the functional safety manager. So this is the hierarchy. You will start as a functional safety engineer, then you can be assessor, then you can be lead, and then you can be the functional safety manager. So here what is the role of functional safety engineer is to make your vehicle fail proof, or even if one subsystem fails, there should be some backup which can overrule the subsystem which has failed. And then later on the vehicle should be operational, or at least in the safe hands. So that is the role of a functional safety engineer. This will be assessed based on the guidelines given in the ISO 26262. That is the specifically for I would say automotive field, where they will be talking like simple scenario that my car is at 80 kilometers per hour and there is a pedestrian who is trying to cross the road. Now after seeing the pedestrian, the distance is 20 meters from the pedestrian and I have applied my brakes, but my vehicle stopping distance should be less than 20 meters. Then only I will be able to avoid the accident. Otherwise there will be the hazardous situation which can cause major impact on the human life as well. So this will be the goal for functional safety engineer, and they will be testing it or assessing your system or your car from this particular safety goal. So this area is also highly in demand as of now, because when we talk about autonomous driving, there is nobody to control it. Your software itself is controlling each and everything whichever is happening inside your vehicle. So you cannot blindly rely on the software, because if there is any corruption of data, if there is any mismatch in the values which are expected, then your system can behave improperly in that case, and then you need a functional safety or monitoring software which will pitch in order to bypass the corrupted data or corrupted values and provide the right information to the system in order to keep it operational as it would be operating normally. So here the functional safety will be playing critical role. The next is also one of the high demand role right now, that is model based system engineer or model based design or model based development. That is nothing but we can code, right? Manual coding can be there. We can code 1,000 lines and more than that also to make one system governed by software. But nowadays we have softwares like MATLAB Simulink, then we have ASCII, that is from ETAS, that is specifically for automotive. These softwares are made to auto-generate the code. So what you have to do is you have to just design whatever you see on the screen, something similar you can design. So if you want DC-DC converter, you can mathematically model it. Similarly, if you want vehicle as your say subsystem, then you can model it mathematically, and there will be some logic inside that. Based on the input conditions, the logic will be checked, and then you will be able to get some output. So this will be the design which you are modeling, or you are modeling your system, and when you auto generate code from this model, it will be capable of generating the efficient and optimized code for you. So this will save up some time for us, as well as it will be more reliable, and you need not to know the coding in detail. You just need to know the tool as well as the system in detail. That's why this role is these days becoming more important, model based system engineering or model based development. So if you see any of the major say suppliers, tier 1 suppliers like Bosch and other Continental is there. Then if you see these companies, then it will be very much obvious that you will see this role they are hiring for, that model based system engineer as well as functional safety engineer. So definitely you will be having MATLAB as one of your subjects during the coursework at Symbiosis. So make maximum use of it, because that software is really costly. Many companies are still not able to afford that software because of the high license cost. So you are getting that opportunity to handle these softwares. So make maximum use of it to learn it. And if you know MATLAB, no one can stop you from entering into the automotive industry, because MATLAB is now replacing each and every sector slowly. So later on, after automotive, you will be seeing MATLAB replacing the manual coding or manual effort, which is happening apart from the automotive industry in the IT segment also. So now after the roles, I'll quickly talk about what are the offerings at Symbiosis. So if you see, all these modern labs are from Lucas Nule. This is a German-based company, and they are into the training and say skilling of say technical persons, professionals, as well as students. So these are very high-end labs which you are able to see. These are capable of simulating each and every system. So if you see at the top left side, it is the automation lab, where they will be simulating the whether it is industrial automation or any other automation from the robotics perspective. Then if you see the right hand side top image, it is the say automotive electronics lab, where you will be seeing the lighting systems. You can actually create a fault and see that your headlight is not working properly, and the error code for the same can be also seen by the diagnostic testing say device, which you can connect through your OBD port. The way you will be doing it in real, in similar way you can simulate everything in the labs, and they are very interactive setups. So you can play with it, you can give various inputs and check what is the system response in that case. So this is a very good part. Then here you can see the bottom left side, you have anti-lock braking system. So ABS is a very crucial, or I would say the critical part when we talk about the braking system these days, because the name itself is saying that anti-lock braking system, which will be reducing the skidding of your vehicle. So if you are applying emergency brakes, then there is a possibility of wheel locking and wheel slipping also sometimes. So in order to avoid that, anti-lock braking system will be there, and you can see with the pressure gauges how much pressure the particular wheel is getting based on the inputs which you are providing. So if you do sudden braking, here you will be able to see the pressure say manipulation or modulation that system will be doing in order to reduce the locking of one particular wheel or slipping of one wheel by applying more pressure to one of the wheels. So that is also very much interactive setup. This exact setup will be there in your car. So it is not like that some model is built and on that you are testing, but it is the actual setup which you will have in your car. That is the advantage here. And then the window or the door panel which you are able to see there, you will be able to understand the power window technology which the vehicles will be having. So how the motor will be operational, what will be the mechanical design in order to roll up or roll down the window, that can also be seen with this particular cut section of car door. And it is real door of a car which is cut in order to see the internal components for the power window. Then we have automotive electronics lab. Here you can see the dashboard also. The entire car dashboard is kept there along with the headlights and tail lights. So here you can understand the CAN communication of the vehicle. So modern vehicle has the CAN communication, that is often known as control area network, and this was again introduced by Robert Bosch in order to reduce the complexity in the wiring. So that CAN network, how CAN communication or how data is transmitted in order to operate your window or say rear view mirrors, headlights, everywhere, that you will be able to tap using this setup, and you can see the raw data in terms of bytes, how it is transmitted and how it is controlling the setup. Then you have automotive components lab, where it focuses on the mechanical components, like you can see engine and the transmission, where you can actually change the gears and the same will be reflected in the transmission. You can see that the transmission also changing gears as and when you are shifting the gear using the gear knob. So that is also something interesting, and these are all again interactive models. These are connected with the electric motors. So if you switch that on, the engine will be operational using that electric motor. So it will rotate and you will be able to see how actually the cylinder and piston is working, how exactly exhaust and inlet valves are functional, and so on and so forth. Then passive vehicle safety lab. So again, this is something where we will be having the airbag setups. Then we will be having some airbag setups. Anti-lock braking system is also part of the safety lab also. Here you can actually deploy the airbag, how it will be deployed in real using the crash sensor input. So you will be having crash sensor input, you can give it and simply the airbag will be deployed. So this is also very nice and interactive setup. Then advanced CNC machine labs. So here the manufacturing part or the exposure to the manufacturing side is also possible through these advanced CNC machine labs. Then again, this is our automotive component lab, where you can see the entire car there. So you can simply play with it, understand what exactly it is, each and every small mechanism. Then you have automotive engine lab. Here we can see the BMW engine kept for display, and you can see in detail what all are the components they are using. So now, very important part, school faculties and trainers, whatever faces you are seeing on the screen, without them it was very difficult. So they have guided me throughout my journey at Symbiosis, and because of them only I am able to pursue my career as per my wish, and I'm able to follow my passion. So all of them are highly experienced in the particular domains they are representing. So if you want to know more about Symbiosis Skills and Professional University, here are the links you can visit. You can see the numbers also for admission department. So you can contact them. Thank you, all of you. This comes to an end, this small webinar session. So I have given my email ID. So if any one of you wants to connect or have more questions or any clarification is required, you can contact me. You can scan the QR code in order to follow me on LinkedIn or connect with me on LinkedIn. So LinkedIn is a really professional platform to connect with industry professionals or leaders, and it will open up the job opportunities for you as well. So thanks all of you. If you have any questions, we can take up now.
For any questions, you can unmute yourself and go. Anyone wants to ask something? You can ask more about, like what job roles are there and what opportunities in Bosch is there. Can we get internship in that? Whatever queries come up to you, which would be beneficial to you, you can ask about it. Anyways, I believe Eshaan has already shared his email ID. So maybe later on, if you want to, ask something, you can ask that way also. And thank you, Eshaan, for this, for this session. The insight you gave about the future auto industry was very good, and I really hope that it will be of use for our students. So also we'll appreciate that we can have more such interactions so that students actually get to know what is actually going on in industry. So we are looking forward to that.
Yeah.
And I would also like to thank all the participants for attending the session. Once again, I would like to thank you, Eshaan, and all the best for your future.
Yes. Thank you, Rajkumar sir.
Okay, Eshaan, thank you.
Yes.
So if anyone if no one wants to ask anything, maybe then we can, end the session. Okay, thank you, everyone.
Yes. Thank you all. Thank you. Bye.